Now we have a car going through a dip whose curvature, that's the curvature here, approximates a circle of radius 300 meters. And the car is going like this. So at what velocity will the occupants of the car appear to weigh 25% more than their normal weight, or their normal weight times 1.25? And normal weight is defined as weight is mg. Now, let's talk about what it means to say 25% more than their normal weight. Here's normal weight again. We typically just write it mg, but the 1 is there so we can do a little math. 25% more than 1 will be 1 plus 0.25, which is 1.25. So 25% more than normal weight will be 1.25 times the normal weight, which is just mg. So it's 1.25 mg. Our free body diagram at the bottom of the dip, because that's where you'll weigh the most, we have the normal force pushing up on the person, mg going down, of course, and the acceleration is up towards the center of the imaginary circle there. We sum our forces. We have normal, positive, mg, negative, ma, positive. We substitute in 1.25 for the normal force. You feel like you weigh 1.25 times your regular weight. Probably should use the word regular instead of normal. Okay. We now have 0.25 mg is equal to ma. Once again, masses cancel out. We have 0.25 g equals a. We substitute in v squared over r for a because it's circular motion. We have this expression. And let's see if we can do this in our head. Multiply both sides by r. That gives you 0.25 gr, and r cancels on the right side. Then take the square root of it to get rid of v squared. Put our numbers in, and we come up with 27 meters per second. A car traveling at a speed of 20 meters per second, which is a little over 40 miles an hour, rounds a flat curve whose radius is 175 meters. Draw a side view free body diagram for the car. Indicate the direction of the acceleration. Use that free body diagram to set up the equations needed to determine the frictional force acting on the car. That frictional force is the force that is pushing the wheels so you can make the turn. Without friction, you wouldn't be able to turn. Solve those equations for the coefficient of friction between the tires and the road.